The next rule I want to talk about, it's called the power of a quotient rule. Now, you just said a quotient rule, all of a sudden they want to show you the power of a quotient rule. And like I say, dog, in terms of that, they are not showing you how powerful the quotient rule is, the one we just done now. No, the power of quotient rule is, it's similar but similar application as long as you understand what's up. So let me show you what's up. So the quotient rules, the power of quotient rule now, it states a different thing now, which is more or less the same also. It says if you have A over B, now it's two different bases. It's A to the exponent 1 over B to the exponent 1. Because the bases are not the same, we can't do much. But if all this is summed up in brackets to one exponent, what you do is you just put the, actually this step shouldn't matter. This step I was just fighting for my life there. I made a small mistake. But then if you have A over B to the exponent M as a whole, you don't panic. You just assign each one of the bases that very same exponent. So this exponent will multiply that one here and will also come and multiply that one here. So this is how it moves. It's going to move from there to here, and then it moves from there to there also, and resulting into same applies. If you have, because here, like I say, it's A to the exponent 1, B to the exponent 1. Like any number is to the exponent of something. Even you can say 0 is to the exponent 0 over 1, doesn't matter. Like you can play around. But anyway, let me not go that deep. Any number is to the exponent something. So here, if you have A to the exponent N over B to the exponent M, mind you, they just have their own exponents. Because the bases are not the same, we couldn't do anything much with the exponents inside. We just had to leave them like that. So according to the power of a quotient rule, this is the same as A to the exponent to multiply the exponent with the first exponent, and then multiply it again with the same exponent, but then on the denominator, and then you get it like that. To apply this in an example of a number, if you have x over y in bracket like that, and then it's cubed, this is the same as, according to the rule, you just take the square, the cube part, which is the exponent, to multiply it by each one of the exponent here. Like I say, invisibly we know, like this is to the exponent invisible 1 is to the exponent invisible 1. So you're going to take that 3, you multiply it with the exponents inside. So this will then result in x cubed over y cubed, and then you're allowed to do this. But then because the bases are not the same here, you just leave it like that. You can't say the one in top, like now that quotient rule, it doesn't apply anymore because the bases are not the same. Taking this rule furthermore, it's for a case where I can use an example of this one, the second one. For the case of this one, imagine where I have x squared over y cubed to the exponent 4. For instance, if I have this case, then I know, oh, this is the same as, according to the rule, this is the same as x 2 times this one first, because like we say, I take this exponent and multiply it here, and then I multiply it here again. So I will have 2 times 4 over y to the exponent 3 times 4. This will result in, when I simplify, I will have x to the exponent 2 times 4 is 8 over 3 times 4 will give me 12. So that would be my final answer in this case, because the bases are not the same. There's nothing much I can do. So now we've spoken about two things: the quotient rule and the power of the quotient rule. Like I say, knowing these names of the actual rule, which rule is named what, it doesn't really matter. It doesn't necessarily matter. We just want to solve problems here. So what matters is for you to understand the actual application of whatever you find. Everything will come together as we cook these things together. But then, like I say, we just want to be able to answer each and every question without getting stuck while we prepare for exam, assignments, and so forth. So in the meantime, while we're waiting for more videos to load, or while we're waiting to make more videos, please like this one already, and please like all our videos, and you can subscribe in on our channel. Press the reminder button so you can be notified every time we make more videos that has something to do with academic work, mathematics, physics, economics, accounting, and so forth and so forth. I am Mr. My Money. This is Simplified RSA. The guys load shedding, but the guys who makes it looks easy. I'm done.